I will be doing integration by parts today. Let's start with the first example. So we have the integral from 0 to pi over 2 of x squared times sine x. Now we choose to differentiate the x squared. So we let u equal x squared and we let dv equal sine x dx. Thus, we have du equal to 2x dx, and we have v equal to minus cos x. Now, using the integration by parts formula, we will get the integral of from 0 to pi over 2 of x squared sine x equal to minus x squared times cos x. Now don't forget your substitution over here, pi over 2 and 0, plus the integral from 0 to pi over 2 of 2x cos x. Now we have to use the integration by parts again on the last term, this term over here. Oops, sorry, this whole term over here. However, we have that the first term, this one, equates to 0 when we sub in both limits. So we are left with the integral from 0 to pi over 2 of x squared sine x equal to the integral from 0 to pi over 2 2x cos x. Now we have to make a new substitution. So we let u equal x and dv equal cos x. Then we will have du equal to dx and v equal to sine x. Don't forget about the 2 over here, otherwise your equation won't work out. Now, what we are left with is the integral from 0 to pi over 2 x squared sine x equal to 2x sine x. Once again, don't forget your substitutions. Pi over 2 naught minus 2 times the integral 0 to pi over 2 sine x now that, if we sub in the different limits, we are left with 2 times pi over 2 times sine of pi over 2, and if we integrate the last term, we get plus 2 times cos x, and then don't forget your limits over here. Then what we get is pi pi plus 2 times 0 minus 1, which then just becomes pi minus 2. For the second example, we have the integral of arc sine x. Now, if we let u equal arc sine x and dv equal dx, then it looks a bit tricky. But to get du, we invert the expression to get x equal to sine u. Remember, we're inverting this expression to get that. Then we have dx over du is equal to cos of u, which is equal to the square root of 1 minus sine squared u, which is equal to the square root of 1 minus x squared. Thus, du is equal to dx over the square root of 1 minus x squared. Now, by using the integration by parts formula, we get the integral of arc sine x equal to x arc sine x minus the integral of x over the square root of 1 minus x squared dx. Now, to solve for the last term, we use substitution. So we let p equal 1 minus x squared. Then we'll have the derivative of p equal to minus 2x dx. Now, subbing that into the formula, we will get the integral of arc sine x equal to x arc sine x plus a half times the integral of 1 over the square root p dp, which is equal to x arc sine x, oops, got the c there, plus the square root of p plus c, which is equal to x arc sine x plus the square root of 1 minus x squared plus c. Because remember, you made the substitution of p over there. For the last example, we're going to use substitution and integration by parts. So we have the integral of cos of square root of x dx. Now, if we let square root of x equal u, then we will get dx over 2 square root x equal to du, and then this becomes dx equal to 2u du, because remember, u is equal to the square root of x. So then our integral becomes integral of cos square root x is equal to 2 times the integral of u cos u du. Now we can use integration by parts. So let dg equal cos u du and f equal u. So then we will have the integral of cos square root x dx equal to 2 times the integral of u cos u du, which is then equal to 2u sine u minus the integral of 2 sine u du, because remember we're using the integration by parts formula. Now if we integrate the last term over there, we will get plus 2 cos u plus c. And now remember, we have that u is equal to square root of x. So you must remember to sub that in at the end. So that then becomes 2 times the square root of x sine of the square root of x plus cos of the square root of x plus c. And there you have your final answer.